Assalamualaikum and hi. Okay, so for today, my team members will explain about the shear force and bending moment in the simplest way. So let's get started.
Hi, good day. My name is Imiji and I'm going to present the introduction and the theory. So, what are beams? Beams are defined as structural members that support the transverse loads at various points along the longitudinal axis of the members. Besides, shear force is a force acting in the direction that is parallel or tangential to a section of a body, while bending moment is the internal reaction to the bending load, which is caused by an external force or moment. Shear force and bending moment diagrams are used to help to perform structural design. There are some applications for shear force and bending moment, which are trolley, cantilever roof, and hanger. But in this project, we will show how the shear force and bending moment involved in skateboard. Skateboard is a type of sport equipment that is used for skateboarding. So the next one is the theory part. There are three types of loads. The first one is concentrated load, which is act on smaller area, and the second one is uniformly distributed load, which is act on a larger area, and its magnitude is determined by its intensity. The third one is uniformly varying load, where the concentrated load that is equal to the area of the loading triangle. There are many types of beams, and for the statically determinate beams, involve three types of beams. The first one is simply supported beam. It is freely supported at the both ends, which are pin support and roller support respectively. The second one is cantilever beam. It is fixed at the one end side and free at the other end side. The third type is overhang beams. The end proportion of the beams extend more from two different supports. These three types of beams is classified into the statically determinate beams because the support reaction can be determined from the equilibrium equation alone. Next, the statically indeterminate beams also involve three types of beams. The first one is continuous beam. The beam is rest on several supports in the same horizontal plane. The second one is probe cantilever beams, where the beam is fixed at one end side and simply supported at the other end side. The last one is fixed beam, where the beam is fixed at the both end sides. Besides, there are four factors that affect the amount of the beams to bend, which are the amount and types of loads, length of the beam, elasticity of the beam, and the type of beams. The table beside shows the summary of the slope for shear force and bending moment for various types of loads. That's all from me. Thank you.
Assalamualaikum and hi. My name is Fatin Aisha binti Hatta, matrix number AA200526. So now I will continue to explain about the methodology of shear and force diagram topic. So this is the method on how to calculate bending moment and shear force diagram. So first thing first, what is bending moment? Bending moment is a moment occurs when a force is applied perpendicular to a point from a distance. The perpendicular force multiplied by the distance from the point. A moment causes a bend in a beam. The standard units are Newton meter, and the clockwise bending is considered negative. Okay, so for the first step is we need to compute the reaction forces and moments and draw free body diagrams. This is the most important part. In any calculation, first thing first is we need to compute the reaction forces and moment and draw a free body diagram. The reaction forces are needed to obtain the bending moment and shear force equations. This is done using the beam's free body diagram. The balance of forces in the beam and the balance of moment in the beam must be determined by using two equations, which is submission force of Fx and Fy and submission of moment. So next, step 2, we need to break the beam into segments and compute shear forces and moment of the piece. To avoid mistakes, cut the beam from left to right before and after each reaction or load. The number and location of these pieces are determined by the external forces on the member. To calculate a beam's bending moment, use the same method as the shear force diagram. So as I mentioned before, we need to break the beam into segments. So this is the first kite. Okay, we need to make a kite just after the first direction of the beam. The force will be considered on the left. In this case, the upper force is 10 kN. So remember that a bending moment is just force times distance. As we move away from the force, the bending moment increases. So as you can see, it is the equation for the first kite. Okay, so as you can see on the figure, okay, this is the second kite, which is kite 2. A 10 kN support reaction and a negative 20 kN downward load now act on the left of our kite. So as we move along our beam, we must now consider both forces. So each meter across the beam adds 10 kilonewton meter, and the first force and negative 20 kilonewton meter from the second. So after x equal to 5, bending moment equation is mx equals to 50 plus 10 times x minus 5 minus 20 times x minus 5. Okay, so this is a note. We write x minus 5 because we only want to know about the distance from PT. X equals to 5. Okay, so for the third kite, the next cut will occur just before the reaction from right support. Since there are no other forces between the support and our previous kite, the equation will remain the same. So we need to substitute x equals to 10 to find the bending moment at the end of the beam. So as you can see, that is the equations. And since our beam is static and no rotation, the beam should have zero moment. Okay, so finally, after all the cuts or after the beam being cut into segment, finally we need to draw the bending moment and shear force diagram. So we can now compute the reaction R, bending moment M, and shear force V for each segment. So below is the example of shear force diagram and bending moment diagram. So this is a simple calculation or method on how to calculate this shear force and bending moments.
Hello, my name is Eng Sao Tang. I will continue presenting the part of analysis and discussion. This figure shows a skateboarder is closing a plank. The weight of the skateboarder is 65 kg and the length of the skateboarder is 0.65 meter. The length, weight, and thickness of the wood plank are 1.8 meter, 0.13 meter, and 0.018 meter respectively. By taking moment at point B, the equation for reaction force A has been determined, which is R naught A equal to P per L, bracket L minus X minus A per 2 bracket. For maximum bending moment, the equation for maximum bending moment has been determined, which is M naught C equal to Px per 2L, bracket 2L minus 2x minus A bracket. Hence, the value of x has been determined, which is x equal to L per 2 minus A per 4. The equation for maximum bending moment has been finalized, which is M naught C equal to P per 16L, bracket 2L minus A square. Substitute all the value for weight of skateboarder, length of plank and skateboard into the maximum bending moment equation, and the maximum bending moment we get is 192.68 Newton meter. Finally, using the formula for maximum bending stress, which is sigma equal to m naught c y per moment of inertia. Substitute all the values such as bending moment, thickness, and weight of the wood plank into the formula, and the maximum bending stress we get is 27.45 megapascal. Continue to the discussion part. This case study-based learning is focused on the general knowledge of bending stress. We need to apply bending stress in our daily life as our case study. We found that the skateboarder playing the skateboard is applying bending stress all of the time. Through this project, we know that the bending stress can be defined by formula sigma equal to m naught c y per moment of inertia, where sigma represents stress, m naught c represents maximum bending moment, y represents the distance from the base to neutral axis, and I represents the moment of inertia. By inserting the value into the following formula, we can get the maximum bending stress of the skateboard. The compressive ultimate strength for common woods is in the range 35 to 55 megapascal parallel to the grain and 4 to 10 megapascal perpendicular to the grain. Hence, the maximum bending stress does not exceed the comprehensive ultimate stress, so the wood plank is able to hold up the stress. In a nutshell, the wood plank will not break because the maximum bending stress is just 27.45 megapascal. Therefore, the wood plank is able to withstand that stress, so it's set for 65 kg skateboarder playing the skateboard on the wood plank.
So as a conclusion, based on the research and study regarding the shear force and bending moment that act on a beam and their application, students must acquire basic static knowledge and use it in this calculation. The previously learned force and moment plays an important part in computing and estimating the bending moment and shear force. For instance, this project proved that the topics that we learn in solid mechanics are capable of building such a strong structure. This also proved that solid mechanics subjects can perform a clear calculation to avoid any mistakes. In addition, this knowledge are helpful for engineers as these are one of the first steps to consider while building a structure or anything. So therefore, I hope that every student realize how this topic can make our imagination beyond the capable and distributing it to our nations. Thank you.